Um, Good morning, everyone. My name is Tannistha, and today I'm here on behalf of my team to present our work in the Cambridge Annual Student Archaeology Conference. First of all, I'm very glad to receive this platform, and I hope it will bring new insights on the topic of health, disease, and population demographics. Today, I'm going to talk about the trends in the mortality profile. Uh, is everything okay with the presentation? Is it visible?
Yes, but are you in the last page? It's showing the results.
Okay. 1 second. Sorry. Yeah, I hope you can see the first page now. I'm sorry about
Yes,
that.
looks great. Thank you.
Um, as I was saying, I'm going to talk about the trends in the mortality profile of extinct and extant human population. This research was recently conducted by me and my fellow colleagues from University of Ferrara, and I'm very happy to share our work today. So the aims of this study has been to primarily do a comparison of the prehistoric sites with the recent mortality profiles on extant population. The literature on the demography of extant population shows various problematics in creating paleodemographic data, such as limitations inherent to the methods for estimating demographic parameters, missing fossil records, etc. We want to understand the issues of paleodemography study by in extinct population by creating a mortality profile and doing a comparison of the groups represented in several archaeological sites. The sites whose individuals have been studied are Grandolina, Cima de Huesos, Crepina, El Centro, Mulagarci, and Liban. The first 5 sites located in different parts of Europe are the sites with paleodemographic data of extinct population, while Liban here in USA is the representation of the modern population. Of course, these are one of the highly researched archaeological areas, but we shall still talk about each of these sites now to create a general understanding about them. The first site that I'm going to talk about is Grandolina. It is located in Sierra de Atapuerca in northern Spain. The layer TD6 date back to 0.9 million years ago, where Homo ancestor remains have been found. There are 10 individuals in total. The study on the fragmentary bones have revealed that 7 of them are immature, while 3 are young adults between the age of 15 to 18 years old. Cima de Huesos is also located in Atapuerca. It is younger than Grandolina, and the species of the fossils found here is Neanderthal. As per the latest studies, there are 4,000 fossil remains, including dental evidence. The total number of individuals have been estimated to be 29 by Bermúdez de Castro. Coming to Mulagarci, it is a site in southern France, which is also Neanderthal remains. The remains are found from an approximate period of habitation around 350 Ka. The collection includes 6 individuals, which are infant, juvenile, 2 children, 1 adolescent, 1 young adult, and 1 mature adult. The next site is El Centro, which is another site from northern Spain, located in the karstic cave system of Surco Ovidio in Fiesto. It is a middle Paleolithic site with 13 individuals, which have been found mostly immature to young adults. Krapina is a Neanderthal site, which is located in northwest Croatia. A high number of individuals have been found here, and based on the dental remains alone, till now total 83 individuals have been identified. Lastly, we would like to take into consideration the human remains from the site of Liban. It is a cemetery from early Middle Ages located in Ohio. It is one of the best preserved cemeteries in America and has a total of 1,327 individuals. So with this background on the 6 sites, we can now move on to the methodological part of the paper. In order to compare the demographic data, we have formulated a protocol through careful analysis of previous researches, and we created a statistical data. The model table that we use in this is based on the methodology created by Wolpoff and Kaspari from their studies in 2006 on the sites of Atapuerca. Here in this table, you can see the different individuals from the sites which have been distributed in arbitrary ranges. There are 10 age groups that have been made from the age of 0 to 5 to greater than 45. We have only taken into consideration the age profiles based on dental analysis, so no postcranial estimations have been mentioned. The age groups have also been adjusted to percentages, which has helped in standardizing the different demographic pools. The first graph that we have created helps in the visualization of locality, spread, and skewness of the numerical groups by indicating their quartiles and median value. Here you can see in the second graph that Liban, which as we discussed before, has a lot more in number of individuals, show a overpresenting in infants and elderly. Thus, it does not give a true comparison of the mortality profile, even though it individually it portrays the mortality profiles of each of the sites very clearly. Therefore, we created a second graph which shows the adjusted database as per the growth model by Bokatappel. The age ranges are adjusted to the assessment technique since there are differences in the dental growth among hominins and modern human species. We can see here in Crapina, Mulagarsi, and Grandolina, there is a similar median that is tilted towards the immature individuals. The three sites present a minor presence of young adults. El Centro presents a gradual growth from immature to adults, and Cima de los Osos have a wave-like pattern with two peaks around the age of 0 to 13 and 16 to 25. So now, based on the mortality profiles that you just saw, I would like you to think about this one question. What do you suspect are the mortality profiles of this population are? Are they attritional or catastrophic? Because we saw the mortality profile in Liban seems to be attritional with the idealized U-shaped profile. We can also see a common mortality pattern in Crapina, Mulagarsi, and Grandolina. It is interesting that when it comes to mortality of these sites in previous literature, all of them mentions traces of cannibalism. El Centro shares similarity with Crapina, Mulagarsi, and Grandolina as we saw before, but the underrepresentations of infants and middle-aged adults give it an erratic profile. The paleodemographic profile of Cima de los Osos shows catastrophic events, even though there is no specification of the nature of the event. Thus, it can be said that the mortality trend of Cima de los Osos could have been fitted as attritional if only one assumes that it is not complete. So, what does these patterns tell us? Is paleodemographic data affected by certain biases? And is there any correlation between the extinct and the extant mortality profile? In our paper, we have come to this conclusion that we should take into consideration the data from prehistoric sites with not just keeping in mind catastrophic or attritional models, because there is a common trend in between these sites, which is noticeable for sure, like cannibalism or any other activities, but there is absence of data which may respond to depositional factors or other criteria. So these data cannot just be compared with demographic studies that we do on modern humans because of all these problems. Also, in terms of statistical analysis, we know that generally model tables are built upon premises such as growth rate, mortality rate, chronological cohesion, and inner mobility. This does not always serve the purpose for paleodemographic data studies due to lack of information, as we see. Thus, in our study, these tables have been adjusted to the analyzed population and have been evaluated against the available data. In all, we can say that there are still issues pertaining to the complete understanding of paleodemography, but statistical comparison model utilized in this research, for example, can give us a scope of in future. Thank you. Here are some references that if anyone is interested in the study, and thank you all for your kind attention.